This is the notes for section 6-7. And 6-7 is about solving radical equations and inequalities. So we're going to do some of the odd problems together, and then that way you're going to go back and finish the even problems. So on number 1, if I have the square root of x equals 8, they start off pretty basic. I want to know what x is equal to, and I have the square root of x. So if I want x, and it's underneath the square root, I can square both sides. So anytime I have the square root of x and I just want x, if I square this, I get x equals 8 squared, 64. Okay, and then we're going to need to check our answers, and you don't have to show me the check, but sometimes we're going to have what we call extraneous solutions, which means extra solutions, and they're not going to work. But I can see where if I plug 64 in for x, the square root of 64 is 8, and so I know that that is going to be a true equation. Okay, so let's do number 2, or I'm sorry, number 3. I have the square root of 2p plus 3 equals 10. Okay, when you have a square root and you're solving for p, I need to isolate my square root or my radical first. So that means I need to get rid of this 3. So I have the square root of 2p equals 7. Now that I've isolated my radical, I'm going to do the same thing. I want this out from underneath the square root sign, so I'm going to square both sides again. So when I square the square root of 2p, I get 2p equals 49. Solve for p. So p equals 49 over 2. Now, if I want to check it, okay, I'm going to take the square root of 2 times p, but p was 49 over 2 plus 3 equals 10. My 2's cancel, so I have the square root of 49, which is 7 plus 3 equals 10, and that's a true equation. So I know p equals 49 over 2. Okay, number 5. I have c to the 1/2 plus 6 equals 9. Now I could do this 2 ways. I do know, or we should know, that c to the 1/2 is the same thing as the square root of c. Okay, so you can rewrite it like this if you want. You don't have to. But I need to isolate my c, so I'm going to subtract 6 from both sides. And I have c to the 1/2 equals 3, or the square root of c equals 3. Now to solve this, again, I would square both sides. So when I square c to the 1/2, remember when I have an exponent raised to another power, I multiply those. So that's c to the first. 3 squared is 9. Okay, and when I check that, square root of 9 plus 6 equals 9. The square root of 9 is 3, so 3 plus 6 equals 9. That is true. And that was number 5. Okay, number 7, I have the cubed root of d plus 2 equals 7. Now if you notice, this 2 is also underneath the radical. So I can't just subtract 2 because it's underneath that radical sign. So if I have the cubed root of d plus 2, to get rid of that radical, I want to cube both sides. Okay, so think about it. If I have x to the 1/2, to get x, I would square both sides. If I have x to the 1/3, I would cube both sides to get x. Just like if I have x to the 1/4, I would take the 4th, raise each side to the 4th power. Okay, so that's what I did here. I'm going to cube both sides, and now I have d plus 2. 7 to the 3rd, so that means 7 times 7 times 7. So 7 to the 3rd is 343. And then when I solve for d by subtracting 2, d equals 341. Now to check, I'm going to substitute this into my original problem. 341 plus 2 should equal 7. The cubed root of 343. And when I put this in my calculator, I get 7 as my answer. So that's a true equation, so D is 341. Again, you don't have to show me the check, but sometimes you're going to have some that won't work out. Number 9. 6 plus the cubed root of q minus 4 equals 9. So first of all, I need to isolate my radical by subtracting 6 from both sides. I have the cubed root of q minus 4, and that's going to be 3. So if I want this radical gone, I need to cube both sides because this is the cubed root of that. So when I cube both sides, I get q minus 4 equals 3 cubed. 3 cubed is 3 times 3 times 3, which is 27. Add 4 to both sides, so q is 31. Okay, if I wanted to check it, 6 plus the cubed root of 31 minus 4 should be 9. 6 plus the cubed root of 27 equals 9. The cubed root of 27 is 3. So 6 plus 3 equals 9, so I know it works. Number 11. I'm just going to work it underneath here. So the first thing I need to do is isolate my radical. So I'm going to add 16 to both sides. Square root of 2m minus 6 equals 16. I'm solving for m and it's underneath the square root. So I need to square both sides. So I have 2m minus 6 equals 16 squared. And 16 squared is 256. I'm solving for m, so I'm going to add 6 to both sides. 2m equals, what is that? 232. Divide by 2. So m equals 232 divided by 2, 116. Oh, did I do something wrong? 16 squared is 256. Add 6. Oh, I think I didn't add right. So let's go back right here. So 256 plus 6. That's going to give me 262. Sorry about that. Divide by 2. So m equals 131. Okay. Let's look. 13 and 15, it's the exact same thing. So isolate your variable or your radical first, and then square both sides. Let's do 17. So I have 3g plus 1 to the 1/2 minus 6 equals 4. So 1/2 power is the square root. Okay, so I need to isolate whatever's to a power. So I'm going to add 6 to both sides. So when I add 6 to both sides, I get this is equal to 10. Now if it's to the 1/2 power, to solve for g, I'm going to square both sides. So when I square this, I have 3g plus 1 equals 10 squared, which is 100. Now I'm solving for g. Subtract 1 from both sides, and I get 3g equals 99. Divide by 3, g equals 33. Okay, and then I could substitute 33 back into this g right here to see if it works, and it will. Now 19 and 21 look a little different because I have radicals on both sides. So when that happens, like on 19, I'll tell you what, let's just do 21 since I can just write it underneath. So we'll do 21 together. On 21, I can't isolate the radical because I have one on each side, but they're already, I have one on each side, so I can just square both sides. And when I square this, I get 6x minus 4. And this one, I get 2x plus 10. I'm going to solve for x by subtracting 2x from both sides. 4x minus 4 equals 10. Add 4 and I get 4x equals 14. Divide by 4. X equals 14 over 4, or 14 over 4 will reduce by 2. So 12, 2, sorry, 7 over 2. Okay, and then I could check that by plugging 7 over 2 into both x's to make sure I get a true equation. Now, when you get to 23 on these inequalities, 23 through 28, I'm going to show you how to do these in class. And then 29 through 30 and 30, they're not hard. They give an equation, they tell you what numbers to plug in, and then you're just going to solve. Okay, so you're going to do the whole page. Okay, and then just like our worksheet 6.6, we're going to grade this at the end of class on the next day.